Hello, grade 7. How are you today? I hope you are fine. Let's start now with module 1, lesson 1, which talking about real numbers. Now, at the end of this lesson, you will be able to classify any real number into rational and irrational number and understand the closure properties in the real number system. So what is a real number? A real number, it's any number that's appear on the number line, such as here, as you see, we have a number line. Now, any number on the number line is a real number, such as negative 7.5, negative 5, negative 7/3, 0, square root of 2, pi, and 8. All of these numbers are real numbers. And the real numbers, it can be classified into rational and the irrational number. So a real number is an union of a set of two types of numbers, rational and irrational. Now, this is here, as I told you. This is the real number. It consists of a rational and irrational number. Now, the irrational numbers is a type of number, or they are numbers that cannot be written in a form of a/b, such as square root of 5, negative square root of 2, square root of 31, negative square root of 6. Later on, I will explain it more and more. And the rational numbers are numbers that can be written in a form of a/b. It could be positive numbers, it could be 0, it could be negative numbers, and it could be fraction, it could be decimal, and not all the decimals are rational. Some of the decimals are irrational, and some of them are rational. Now, as you see here, we have the rational numbers. And we have an integers, and we have an whole numbers and natural numbers. The natural numbers means that's all the numbers that are 1, 2, 3. So they are the positive integers starting from 1. There's no decimals, there's no fractions, there's no negative numbers, there's no 0. This is a natural number, 1, 2, 3, 4, and so on. The whole number, they are the natural numbers, 1, 2, 3, 4, and you add a 0. So the whole numbers are non-negative integers. They are all the positive integers starting from 0. So the difference between natural and whole, that the natural, there's no 0. In whole, we have a 0. So the whole numbers, we are here, we are talking about positive integers, 0, 1, 2, 3, 4, and so on. Now, the integers are numbers. These numbers, it could be negative, it could be positive, and it could be 0. But there's no decimal and there's no fraction. So, and the rational numbers here, they are a decimal, it could be fraction, it could be positive, negative, 0. This is irrational. Now, from the graph here, or from the Venn diagram here, we can say that all the natural numbers are whole numbers. So let's draw now an arrow here. So all the natural numbers are whole numbers, and all the natural numbers are integers, and all the whole numbers are integers. But say here now that not all the integers are whole numbers, and not all the whole numbers are natural, because as I told you, we have a 0, and 0, it's a whole, but it's not natural. So because of that, I will say now that not all the whole numbers are natural, but all the natural are whole numbers. So let's define now the rational, the irrational, the integers, the whole, and the natural numbers. What are these? Let's see here. Now, the rational numbers, as I said before, are numbers that can be written in a form of AB. If you see the number and you can write it as a numerator over denominator, integer over integer, like 3 over 5, 1 over 2, 3 over 1, 1 over 3, 3 over 100, and so on, this will be a rational number. What about the decimal number? If you look at the decimal number, we have two types of decimal numbers. One is terminating and one is not terminating. Now, terminating means like 0.25. This is a decimal and it's terminating. Terminating means its end. So the number here is its end. It's terminating. But some of them is not terminating, such as 0.33333, and so on. Now, if the number like this one here, it's not terminating, but it's repeated. As you see here, the number 3 is repeated more than one time. You can write it as 0.3 repeated. It will be rational number. So if the decimal, is terminating, or if it's not terminating, but it's repeating, it's rational. Now, one of you ask herself, what about if the number is not terminating, like 0.31917243210, and so on? What about this number here? This now is not terminating, but it's not repeating. Yeah, for this type of numbers that's not terminating and not repeating, we call it irrational numbers. So the irrational numbers are numbers in decimal form that cannot terminate, or they didn't terminate and do not repeat. So let's now classify the decimals here. Any decimals, it's terminating or it's not terminating. If the number is terminating, as I told you, like 0.7, so it's going to be rational. And if the number is not terminating, we have two types, repeating and non-repeating. If it's repeating, like 0.32 or 315, 315, 315, and so on. So it can be written as 315 thousandths. So here it's repeated. So this is an irrational. But if we have a number that's not terminating, such as this big number here, and it's not repeating, we will say that this is not rational, or you can say irrational. Not rational or irrational has the same meaning. Now, so let's define them as I told you before. The rational number is a number that can be written as a quotient of two integers. Who can give me one example now? Like 2 over 3, like 0.4. 0.4 is a decimal, yeah, but it can be written as 4 over 10. Now, like -3, this is a rational number. Now, let's repeat what are the integers. The integers, they are the numbers like -3, -2, -1, 0, 1, 2, 3, and so on, consisting of the negative integers, 0 and positive. So the integers are negative, positive, and 0. These are the integers. The whole numbers are numbers like 0, 1, 2, 3. The whole numbers, there's no negative, there's no fraction, and there's no decimal. So here, the whole numbers mean there's no fraction, there's no decimal, and there's no negative numbers. And the natural numbers, they are numbers. We can say like counting numbers. Other name for it as a counting numbers. You have to start count from 1, 2, 3, and so on. These numbers, they don't include 0. They do not include negative numbers. There's no fractions and there's no decimals. This is the natural numbers. Now, let's go to the irrational. So here, not integers, whole numbers, natural numbers, or rational numbers. Now, what about the irrational? The irrational that cannot be written as a quotient of A over B, such as square root of 5. Now, what is the square root of 5? Square root of 5 approximately, it is a 2.2360679 and so on. Look at this number here. Is it terminated? No, it's continue. Okay, my second question now. Is it repeated? No, it's not repeated. So this is an irrational. Now, so what are the real numbers? As I told you, the real numbers consist of rational and irrational numbers here. It consists of rational numbers and irrational numbers. And the rational numbers consist of integers, whole, and natural numbers. Shall we take more examples now in order to understand what are the rational and what are the irrational numbers? Here now, cubic root of 27. What is the cubic root of 27? It's a 3, is it right? Now, look at the 3 here. Can I write 3 as a fraction? Yes, it can be written as a 3 over 1. So, since it can be written as a 3 over 1 as a fraction, so it will be rational numbers. Now look at pi. Pi, it's a 3.14. Sorry, give me a minute, please. 3.14287 and so on. So, is it terminated? No. Is it repeated? No. Can be written as a decimal, as a fraction? No. So it will be irrational numbers. Now, the square root of 27. What is the square root of 27? You can see here, it's 3. I can say, so you can write it as 9 times 3. So it's a 3 square root of 3. And if you look at square root of 3, it is an like it's 1.732 and so on. Multiplied by 3, it's going to be a non-terminating number and non-repeating number. So the square root of 27 is 5.19615. So it's not terminating, it's not repeated, so it's going to be irrational numbers. Now, what about the square root of 81? What is the square root of 81? It's 9, yeah. 9, it can be written as 9 over 1, so it is rational numbers. Now, what about the cubic root of 16? Cubic root of 16. Like, give me 3 number. If you multiply it 3 times, you get 16. Now, cubic root of 8 times 2. So it is a cubic root of 8, which is 2, times square root of 2. So now it is an irrational numbers. And look at the last one here. 0.4 and the 4 is repeated. So here now we have a decimal number, but it's not terminating, sorry, but it's repeated. So it's going to be rational numbers. Now, this is an example of how can we classify an irrational and the irrational numbers. Tomorrow we will talk more examples in order to explain, or in order to know what is the difference between the rational and irrational. And then we will start with, if we have a real number, I add it to other real number, what their answer will be. Is it real or no? For the subtraction, for the multiplication, and for the division. This will be explained tomorrow. Thank you for listening.